So if you want to, just at the bottom of page 417, if you want to highlight this, we call any equation where the x is inside of the logarithm a logarithmic equation. And what we're going to do today is we're going to look at how all of the log laws that we've been practicing can be used to solve both logarithmic equations and exponential equations. And that, being able to solve those equations, what we're going to do next in 5.8 is look at all the places in real life where these equations show up. So we'll look at exponential growth, we'll look at decay of materials, we'll look at compound interest, we'll look at sound, decibels, earthquakes. All of these things need logarithms to solve them. And so we have a number of real life situations where we use this, and we've been developing our skills along the way so that we can solve these equations. So all of our practice with log laws has been developing so we can solve these equations. Now we're going to practice solving the equations and then be able to apply them to real life situations. So the idea of logarithmic equations is that it's hard to solve logs. Exponential form is way easier. You're way more used to solving exponent stuff. So our goal is to take a log equation and change it to an exponential equation. But in order to change it to an exponential equation, first of all, we need to get a single logarithm. So we're going to use our log laws to get one logarithm equals a number, and then, and I'm going to write this in a different color. It has been a 20-year struggle for me trying to figure out how to get students to remember this green step. And I don't know why it's so hard to remember this green step. So maybe I have to just start wording, you solve log equations by changing to exponential form. Maybe I have to just keep repeating that over and over again. Because people will remember, okay, I remember I have to do this math to get a single logarithm, and then all of a sudden they get stuck and can't remember the next step. And then we're going to solve and check for extraneous roots, because you can't take the log of 0 or a negative. So sometimes in solving logarithmic equations, you get an answer, and the answer is 5. But if you plug 5 back into the original equation, it would force you to take log of -7, which is impossible. So it is something we always have to check log equations. There's a few things in math you always have to check the equation in the end. Square root equations, when you square both sides, when you get an answer, you always have to check to make sure that you weren't taking a square root of a negative number originally. This is another one that we have to check. So what does it look like? First of all, if I want to solve this equation, I'm going to use my log laws to get a single logarithm. Do I have a log law that says a log plus a log you can put together? Absolutely. Adding two logs with the same base means that you can multiply. So I can put the 9x and the x together inside a single log, and I get log 3 of 9x squared equals 4. Now, this is the green step. Once you have a single logarithm, you say, this is hard for me to understand, but I can change it. The base is 3, the exponent is 4. I can change it to exponential form, And it turns it into an equation which I've done before. Have you solved an x squared equation? Absolutely. How can you solve an x squared equation? Well, you could get that x squared by itself. 3 to the 4 is 81. I could divide both sides by 9. I could square root. And this gives me a possibility of 2 answers, right? I have one answer where it's positive 3, one answer where it's negative 3. And I have to check both of these. They both could work. One could work. It's possible that they both don't work. So we go back to our original equation, and we just check if I plug in 3, will there ever be 0 or a negative in either of the logs? In the first log, if I plug in 3, I have log 3 of 27. Positive number, perfect. Don't have to worry about it. If I check the second one, log 3 of 3. Positive number, no problem. This one is good. If I check negative 3, 9 times negative 3 is negative 27 inside a log. I don't even have to check the other one. If it doesn't work once, I put an X through it. That root is not possible. Now, depending on the exam, very common mistake here. Someone does x squared equals 9. What's the very common mistake in the next step? What do people forget? The plus or minus. Forgetting that plus or minus is probably only a half a mark on the exam. But the exam might have said crossing out this extraneous root was worth 1 mark or another half a mark. I'm not sure. So if you forget the plus or minus, you're going to lose a half a mark. Then you could lose another mark or another half a mark because you won't have something to cancel out. So very careful in those steps there. These are log equations. Log equations we always solve by seeing if we can get a single logarithm, changing to exponential form, and then solving. There are some log equations where I'm going to show you there is sometimes a possible shortcut, but generally this is the way that we're going to go about it. So I'll show you the shortcut in example 2, but for this one you can circle questions 3, 4, and 9.